right, guys. This is a great time to put your phones away. If you did not pick up a calculator and you don't have one, now would be the time to get one. Oh, sorry. Let me pause the recording again because Okay, guys, for real this time. We're going to get started. So, phones away. I appreciate seeing a number of periodic tables out. That's excellent. I'm going to move this Zoom over here. All right, so your warm-up. All right, who can say it without singing it? All right, looks like a bunch of people have an answer. So how about 1, 2, 3, go? Yes. Okay, so if you are a Broadway fan, you knew that off the top of your head because it's from Rent. If you're not a Broadway fan, you probably didn't have that conversion off the top of your head, minutes per year. It's not something we usually talk about, right? But it's pretty straightforward to get there, right? So how can we get there? How can we get to minutes from a year? Yeah, Sarah? Okay, beautiful. I would have done it the opposite direction, but that's totally fine. The way you did is totally fine. And Carmen, did you have anything to add to that, or did you do it the opposite way? Yeah, okay. Right, so we're starting with 1 year, right? And we're going to minutes. So this is my given. This is where I'm going to. And we could say, okay, like Sarah and Carmen did, you could say, all right, 60 minutes in an hour, and then times 24 hours in 1 day. And you said that was how many? What was your product here? 1,440. Okay, so that's now we're in hours, right? So, we're 1,440 minutes because we're still here, and then we got to multiply that, right? Because that was 24 hours in 1 day, and we got to multiply that by 365 days in 1 year, and eventually we get to our answer. $525,600 minutes in a year. Minutes per year. Okay, so depending on the way you do math, you may have done this a number of different ways, okay? There's lots of ways to get from point A to point B. I would like us to do a little reset because I started grading yesterday's quizzes last night, and there's a lot of good stuff, a lot of great work, but also some difficulties with the setup. So I want to try doing a very, very slight change to the setup, and I would like you guys to all do it with me, even those of you who have been doing the math your own way, because it's going to get more complicated. We're going to have questions like this, but with chemistry, okay? And so I would like you to please do it the way that I'm doing it on the board to make sure that you understand how that works. When we are done with this unit, you can do math however you want, okay? But for this unit, also so it makes it easier to grade, because it took me 2.5 hours to grade first period yesterday. I would like you to set it up the way that we're doing it in class. So this is, oops, I didn't want to do that. This is a slightly different approach. Rather than talking about these things as fractions, we're using this sort of railroad tracks approach here. And I can do the same exact question, but I don't have to do
Students will arrive without a pass. Again, this included our call. Please do allow all students into your classes, and please make sure to email Mr. Valerio and the level administrator and students arriving without a pass. Have a wonderful afternoon.
Okay, so I'm going to do the same problem, but rather than doing 2 or 3 different calculations, I'm going to set it up so I can just do it once. So the key here is the way we've always been doing it so far, or the way I've been doing it on the board. Not all of you have done it this way. I would like you to start doing it this way if you haven't, is we identify what is our starting amount. What are we starting with? 1 year. That's our, oops. That is our starting amount. That's our given. So that's what I'm going to put up here. 1 year. Okay? Now, one of the keys to getting this right is that nothing goes under this. This box, you can scribble it out or X it out or whatever you want. This is not a conversion. This is your given amount. So there's nothing underneath it. Okay? So I'm starting with 1 year. The next conversion needs to take me from years to something else. So I need to take my years and put them down here. Okay? And I'm going to, whatever I'm converting years to needs to go up here. Because that way I can cancel out the units of years. And I no longer have years in my answer. So right now I'm starting with years. I don't want years. I'm going to put years down here. And then we talked about 365 days in a year. So that's what I'm going to put up here. Days per years. The years is just 1. The days is the 365. The next conversion I'm going to do, what's going in the bottom? Days. Because I need to get rid of this days. Because right now I've canceled out my years. I also need to cancel out my days. And what's going to go on top? What am I converting days into? Hours is probably easier. You might know how many minutes there are in a day off the top of your head. I don't. So hours is 24, days is 1. Okay? So now I can cancel out my days. What's next? Right. Where am I putting the minutes? On top or on the bottom? Top. Because that's what I'm looking for. Okay? I got to take hours and put hours down here. All right? So this is the 60 minutes per 1 hour. All right? All of these things could be used the other way around. Okay? But using the units of what I'm starting with and progressing with the units is how you're going to do this correctly every single time. All right? Now, what do I do with all these numbers on the top? Multiply them. Multiply, multiply, multiply. If I had more, I would keep multiplying. Okay? What I have on the bottom, I've got 3 ones. Doesn't really matter. 1 times 1 times 1 is 1, right? And so this would give me 525, 600 over 1, which is just that number, right? So multiply by the top, divide by the bottom. So what are my units? Minutes. And I know that, and I can double check it because I have minutes right here. So this should be the units for my answer. And then I can go back and look at my question and say, is minutes what I was looking for? Why, yes, it was. How convenient. I have actually answered the question. Okay? So I only have to plug these numbers into the calculator once instead of having to do 3 separate stepwise conversions. And it's not so much the math part that matters here, right? For a lot of people, punching something in 3 times versus punching in a longer equation once isn't going to make that much of a difference, right? It's making sure that you're multiplying and dividing by the right things that makes the difference. That's why I want you to set this up. This is called dimensional analysis. That's this type of computation that we're doing here. And it's useful outside of chemistry as well. Obviously, this isn't necessarily something that you would want to know every day, but while you were listening to the Rent soundtrack, it might have crossed your mind to wonder whether this was just a nice round number because it made the song sound good, or if that was actually real. Okay, so, but like I said, I can use all of these conversion factors upside down. Say I wanted to know how many days there were in 5 years, okay? That's not going to work because that's the same way. Say I wanted to know how many years it was going to take if I had 525,600 days. How many years would that be? If this was days instead of minutes, how many years would that be? Well, my conversion factor here is still days per year, right? But instead of drawing it like this, days over years, I need days to be down on the bottom. I need to have days and years on the years on the top. Okay? I wouldn't put my 365 here because it's not 365 years per day. It's 365 days per year. So the 365 is going on the bottom, and it sounds like Haiwan has an answer for us. 6.94 years. Okay. So again, this is 1 year. The same conversion factor, just used to make a different type of conversion, just flipped over. The same thing is true for chemistry. Molar mass can be X number of grams per 1 mole, or 1 mole over X number of grams, right? So your worksheet today asks you to do a little bit of extra annotation for me. I had one of my first period students who got 10 out of 10 on the quiz yesterday, had a beautiful annotation on her page. Everything was super organized. It was lovely, and granted, I have terrible handwriting and mine wouldn't have looked that nice, but it was the organization and the setup and the fact that she was looking for the starting amount and what she was solving for, that helped her get a 10 out of 10. So on this worksheet, we've got some gram to mole conversions, some mole to gram conversions, some molecule to mole conversions, some mole to molecule conversions. All right, so what I want you to do with each question before you start setting anything up is figure out what's your starting amount, what units are you solving for, and which factor are you going to use? Are you going to use the molar mass, or are you going to use Avogadro's number? If you answer those questions before you even start, you increase your chances of setting it up correctly. All right, and then if you use this to set it up, your chances of success get even higher. So what's my starting amount here? Manuel, what am I starting with in this question? Thank you. 4.5 moles. Somebody asked, does it matter that it's 4.50? If we were caring about significant digits, it would matter, but we don't. We're leaving that behind. You can learn about that in IB if you take IB chemistry. Or physics, actually. Okay, so we're starting with 4.5 moles. And Giselle, what are we solving for? What are our units that we're looking for? Grams, thank you. And Rodas, what conversion factor am I going to use to go from moles to grams? Am I going to use Avogadro's number? Am I going to use molar mass? This one? I see a mole here, but I don't see grams anywhere. So this is not going to be the one I'm using because I need something that takes me between grams and moles. Okay? So I need something that has both grams and moles in it. That's going to be my molar mass because my molar mass has grams and moles either way. Okay? So identifying that you're using the molar mass and not Avogadro's number will help a lot of you set things up correctly according to the quizzes I saw yesterday. So, where does my 4.5 moles go in my setup? Where do I put it? At the top? Over here? Left. Top left. And what goes underneath? Scribble. Yes. Nothing. Or an X, or you can leave it blank. You can put a 1 there if you want to, but I'm finding that putting the 1s is confusing some people because some people are trying to put a unit for that 1, and there's no unit. It's just 4.5 moles. We're not converting. This is not a conversion factor. So I prefer blank or scribbled or X'd out. So what units are going down here? Alexander, what units do I need at the bottom here? Grams, moles, moles. Because I have moles up here. I got to take that mole and put it down here. And then what's on top? What units are on top? Yes. Oh. Yes, grams are on top. Okay, so I haven't even looked at numbers here for this conversion, but I already know which way it's going to go. I also already know, without doing any calculations, one of the numbers that I'm going to put in these boxes. Which one do I know? 1, where does it go? 1 gram or 1 mole? 1 mole. All the conversions that are going between grams and moles or molecules and moles is always per 1 mole. So this part now I have to figure out. So this is where I have to go in and say, okay, BA, N, and O, and I have to start calculating my molar mass. So I get my periodic table, which everyone should have out. And I find barium, which is down here, number 56. 37.33. How many bariums do I have? 1, just 1. There's no subscript here, so it's just 1. Nitrogen. How many nitrogens do I have? 2, thank you. This was another common mistake. A lot of people multiplied the 2 or the number outside the parentheses by this one, but forgot that it also gets multiplied by the subscript for the first element. So I had a lot of people correctly say the number of oxygens, but not the correct number of nitrogens in something like this. Yes? Sorry, so this is oh, sorry. It's H. It's 14.01. There we go. Hi. Thank you. And this barium, sorry, was 137.33. And so my nitrogen is going to be multiplied by 2. My oxygen, 16.00 times what? 4. Okay. I do this calculation. I'm going to add it all up, and that's going to be my molar mass in grams per mole. So that's what I'm going to put here, grams per mole. Right? So whatever answer I get here from my molar mass calculation goes up here. I'm just going to, for now, put MM, let you guys do that. What am I going to do with these 2 numbers? Multiply. Okay? 4.5 times whatever I get from my molar mass. And that's going to be my answer. What units are my answer going to be in, Maeve? Nope. Just grams. This is going to be grams per mole. And that becomes this, grams in 1 mole. But this cancels out my moles, so all I have is grams here. And conveniently, that's what I was solving for. So that's how it works out. All right, so when you get this number, it goes up here, multiply, and that's going to give you your answer and your units. Yeah. Yeah. So that's the kind of setup we're looking at. What I want to do is set up one more in just a second. So this first question was solving for grams starting with moles. This next question, what's our starting amount? It's 24 grams. So this time we're starting with grams. Let me move this down a little bit. Again, the 0.0 doesn't matter because we don't care about significant figures. What are we solving for? Moles. So Amaya, what am I going to use as my conversion factor? Between grams and moles? Yes, I'm going to need my molar mass. Okay? So in this case, I'm starting with 24.0 grams. So what goes down here? Grams. Got to have grams. And what goes up here? Moles. That's what I want. I got to cancel out my grams. So I'm going to need my molar mass. What number do I already know that I'm going to put in here? A 1, and where does the 1 go? On the top or the bottom? On the top with moles. It's always per 1 mole. So when I calculate my molar mass, I'm going to stick it here. And then I'm going to take this number and divide by the molar mass. Okay? Because it's on the bottom. Whatever's on the bottom, we need to divide by. When it's just a 1 on the bottom, we don't worry about it. But if there's an actual number here, then we need to divide 24 by whatever you calculate for the molar mass. Okay? So last time, we had grams on top and 1 mole on the bottom. This time, we've got grams on the bottom and 1 mole on top because we are starting with and ending with different units. And finally, number 3, what is my starting amount? Augustine, what's my starting amount for number 3? Oh, sorry guys, this is a typo. This is 10 to the 19th. So that's an exponent. But yes, that's the right one. And Augustine, what am I solving for? Sorry, that was, yep, so that was molecules. Sorry, it's just a long word. And solving for moles. So, Augustine, which conversion factor am I going to use for this one? Molecules to moles. Can I use my molar mass? Nope. Evelyn? This is where I'm going to use Avogadro's number. This is 6.02 times 10 to the 23rd molecules in 1 mole, or atoms in 1 mole, or formula units in 1 mole. Okay? So this is where I'm using Avogadro's number. I'm starting with my starting amount. Molecules. So what needs to go on the bottom here? Yeah, so I need the molecules down here, and that's going to be where my 6.02 times 10 to the 23rd, sorry for my terrible handwriting, goes. And then what goes on top? 1 mole. Excellent. Okay. So now I'm taking my 2 times 10 to the 19th, dividing it by 6.02 times 10 to the 23rd. And what units is my answer going to be in? Moles. Yep, because I cancel out molecules, and I'm going to end up with moles in my answer. Do I need to calculate the molar mass? Nope, doesn't matter. I mean, you can if you want to, but you're not going to use it, so you're kind of silly. So I'm not using the molar mass because there's no grams in the question. If there are grams in the question, I'm using the molar mass. If there are molecules or atoms or formula units in the question, I'm using Avogadro's number. Either way, it's the same idea. We're still playing with our units, using our units as our guidepost for where things are going. Yes? This is on the bottom, divide. So you multiply across the top, divide by the bottom. No, 2 divided by 6.02. Just like if you're if I'm writing a fraction 3/4, that would be 3 divided by 4. Yes, because look at your exponents. You're taking 10 to the 19th and dividing it by 10 to the 23rd, so that's going to be -5, I think should be your exponent. Right, yeah. So that's going to be 3 point something times 10 to the -5. Or 4, something like that. So you can put it as, the answer that Liam's getting is something like 0.00003, something, 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 okay? And you can leave it like that if you want to, or you can convert it to scientific, 1, 2, 3, 4, 5, and make it 3 point something, something times 10 to the -5th. One thing we'll do quickly tomorrow is a little calculator review, just to remind you what to look for, because I definitely had some folks who did not realize that their calculators were in scientific mode and gave some answers that were just off by a few decimal places. I tried to give as much credit as I could because I don't want that to be the problem. But all right, any other questions right now? Yes. Yes. All right, any other general questions? Okay, so work on this sheet. We're going to have time to work on this tomorrow. I'll also give you some time to prep for makeups. I apologize, tomorrow and Monday I will not be here at lunch. I will be down in the art gallery helping with the prom ticket sales. So that's one reason why tomorrow is going to be a work day, catch-up day, because I'm not giving you the chance to come in and ask for help at lunch. Okay? All right, I'm going to stop my recording.